So today we are going to be doing two different ideas. We're done with chapter 9. We're going to be focusing on reviewing for the final exam and learning some ideas to get us ready for integrated 2. So the first thing I want you guys to get from Google Classroom under classwork is notes multiplying binomials. It should look like this. Okay. You can access it, again, you want to from your Google Classroom classwork, not from the stream, because on the stream you can't edit. Otherwise, you can do it on a piece of paper and submit it that way. The other thing we're going to be talking about today is also review for the final exam. So I have one that's classwork, final review number 1. And so we're going to be doing both of those today and submitting both of those. You will have a homework tonight, final review number 1, homework final review number 1. So those are the 3 things. Okay, the first 2 we'll do here in class. The other one you will have for homework. So let me get started. So again, multiplying binomials. Let me get it on my tablet and we'll do that. So this is the worksheet, okay, that we're going to be doing. And again, remember, if you're doing this on your phone or tablet, you're going to hit the little pencil so you can edit, okay? And don't forget to save at the end. So this is review of what we had actually done earlier in the year, multiplying binomials, okay? Binomials, we got these 2 terms. That's a binomial, and this is a binomial. And we're going to multiply x plus 4 times x plus 2. And we're going to set it up using the box method, or we call it also an area model. And so it doesn't matter if I put x plus 4 on top or x plus 4 on the side. Okay, one of them's going to go on the top, one of them's going to go on the side. Now, when I do this, I actually like to have my sign right next to it. So I'm just going to adjust this. I'm going to grab from my colors here, white, and it works almost like a whiteout. And I'm going to come here and I'm going to erase that plus and erase that plus so I can show you where I personally put it. So let me get my black back. So I would put the plus right in front of the 4 and right in front of the 2, or whatever sign it happens to be. And now we're going to multiply these out. So the x is going to multiply with x, and then the x is going to multiply with 4. So x times x is x squared. X times 4 is 4x. Now the 2 is going to multiply with the x, and then the 2 is going to multiply with the 4. So 2 times x is 2x. 2 times 4 is 8. And now I'm going to combine like terms. So the like terms I have, this 4x and this 2x are like terms. So I'm going to add those together. So I end up getting, I'm going to write it over here. So x plus 2 times x plus 4 is equal to x squared plus, and I'm going to add my 4x and my 2x and get 6x plus 8. And that is my answer. Okay, and that's multiplying binomials using the box method. So we're going to come and do more of that down here. So here we have x plus 3 and x plus 5, okay, and we're going to multiply these together. So x times x is x squared. My x times 5 is 5x. Now I'm going to take the 3 times both of these. 3 times x is 3x. 3 times 5 is 15. Again, I'm going to combine like terms. These are like terms, so I'm going to add those up. So I'm going to end up with x squared plus 8x plus 15. And just so you know, these were binomials because they're 2 terms. This is a trinomial because it's 3 terms. And this is actually a quadratic, and we're going to see that next year in integrated 2. Our main focus next year in integrated 2 are quadratics. Okay, this is a quadratic. If I was to graph this on a graph, it would actually be a parabola, a U-shaped graph. So now let's look at the next one. Okay, now again, this is an x plus 4 and an x minus 3. I personally am going to really emphasize this. I put the minus right in front of it. I don't like to stick it here where you might lose it. And we're going to multiply. So x times x is x squared. X times a negative 3 is a negative 3x. 4 times x is 4x. And 4 times a negative 3 is a negative 12. So you always want to be careful with your signs. So combine like terms. I get x squared. 4x and a minus 3x is 1x, or even just x minus 12. So next one, this time, they did not set it up for us, okay? They drew the box, but they did not set it up. So I'm gonna take my x plus 1, and again, it doesn't matter which side I put it on. Let's say I put it here, x. And notice I'm gonna put my plus right in front of my 1. I don't like to stick it in between. Now this is an x minus 7, it's hard to read on this. So that's x, and again, do not stick it like this. You're gonna lose it, okay? You're gonna forget about it. You're just gonna grab the 7. So stick it right in front of the 7 like that. So now I'm gonna multiply x times x is x squared. X times 1 is x. Negative 7 times x is a negative 7x. And negative 7 times 1 is a negative 7. So now I'm gonna combine like terms. And my like terms, this and this are like terms. So I'm going to get x squared, negative 7x plus x is minus 6x minus 7. Okay, again, it's so important that you can understand how to multiply these together for next year in Integrated 2. Our main focus in Integrated 2 are quadratics, solving quadratic equations by factoring quadratic formula and completing the square. Right now that doesn't mean anything to us, but next year we're going to be doing that all of the time. So knowing how to multiply these out is going to be very useful. Okay, so again, I'm going to write these. I'm going to put my x minus 2 here. It doesn't, again, matter which one goes where, but do not stick your minus right there, because when you do that, you might just come and grab 2, okay? A little obvious when I have it in a bright purple, but you know, if you're doing it in a pencil, you might not notice it. Minus 2, like that, negative 2. And then my 2x, and again, I don't want to stick that here, because when I do it, I'm just going to maybe focus on my 6, and it's not a 6, it's a negative 6. And now we're going to multiply these. 2x times x, 2x squared. Okay, we're always multiplying to get these boxes. 2x times negative 2, negative 4x. Negative 6 times x, negative 6x. Negative 6 times negative 2, positive 12. Okay, negative times negative is a positive 12. And again, combine like terms. So those are my like terms. So I'm going to get a 2x squared minus 10x plus 12. And that's my answer. So now on the back side of this, they're going to introduce another way of doing this, and it's called FOIL. If you ask your parents to help you on something like this, they probably grew up learning this with probably the FOIL method. So I'm just going to mention it to you. And on the back side, it actually says, let's do it without it, but I'm going to do them all with the box, because I think right now for us, this is going to be the safest way for us to do it. And next year, you're going to have to understand how to use this box when we do the opposite of multiplying, when we do something called factoring. And in Integrated 3, again, we're going to be doing it with bigger, like trinomials, okay, or polynomials of bigger degrees, and it's helpful to understand how to do this box method. Okay, so I'm going to just real quick mention this. I'm going to grab some different colors. And let's say first I start with green. Okay, so the method that your parents probably learned is called FOIL. Okay, now FOIL, let me kind of spread it, get it down a little bit more, maybe not so fat of a pen. Okay, so FOIL first, and first is, let me get it back, first is when I take the first one times the second one. I mean, the first one and the first one and the first one and the second one. So first is this. First. So I'd be multiplying this times this, which gives me 2x squared. Then I would be multiplying my outer. Okay, so my outer x times negative 6. So what you'll notice is happening is the x is multiplying with both things. We kind of think of this as like a double distribution. So the x is distributing to both of these, and then eventually the negative 2 is going to distribute. So right now I'm distributing the x to the 2x, and the x to the negative 6x, okay? And so when I take x times negative 6x, I get negative 6x. And then, let me get another color, and this is going to be inner. And so I'm going to take my negative 2 times my 2x, negative 2 times 2x. And see, sometimes you might lose your sign this way, so you do have to be careful. And that's going to be a negative 4x. And then, let's see, what color haven't I used? I used red. Last. And your last, your negative 2 with your negative 6. Okay, so you can see how it kind of looks like almost like a little person. The parentheses here almost look like ears. This looks like a mouth and the chin, and like that's the top of the head. So again, I'm taking my negative 2 times my negative 6, which is a positive 12. And you'll notice I'm getting the same things. 2x squared minus 6x minus 4x positive 12. And then I would combine it. So let me just write out the words again. This was first, outer, inner, last. Okay. And again, here was our first, this was our outer, this was our inner, this was our last. So right now, I actually think using the box will be a little more helpful. What you need to remember when they don't draw the box for you is you have to look to see how many terms you have. If you have 2 terms, you're going to need two boxes in a particular row or column. So here this is 2 and 2, so this would be a 2 by 2. 2 by 2. Each term has its own little box. So let's flip to the next page. And on this one, it was asking us if we notice another method. So here I'm going to write out what we just were doing, okay? So we were doing, again on this, we can use the method FOIL, okay? So first, outer, inner, last, okay? So let me just show you what I mean by that here. So I'm just going to rewrite this out. So let me just write it out in, let's say, black, okay? So this is x plus 4, x plus 4. Actually, I'm going to write it down here so I can, x plus 4 and x plus 6. And so my first is my first term times my first term, first. So that is our x squared. Our outer, the 2 on the outside, x times 6, which is 6x. My inner, the 2 on the inside of my parentheses, 4 times x, which is 4x. And my last, the 2 at the end of them, so that's 4 times 6, which is 24. And then when I'm adding this up together, okay, this is going to be x squared plus 10x plus 24. So again, that is FOIL. So now on these ones, it does say do not use the box method, but right now I'm going to kind of white that out. I want us just to practice using the box method because I want us to be good with these. So I'm just going to ignore that. Okay, and we're going to do the box method for these so that we're good with those. Okay, so on this one here, again, they're not drawing it first, but it's 2 by 2. So I've got 2 terms, so I'm going to have a 2 by 2. And it doesn't matter which one goes here. Let's say I put my x plus 6 and my x plus 7. And then I'm going to multiply and get x squared, 6x, whoops, 6x, 7x, and 42. And now I'm going to, again, combine my like terms. And when I do, my answer is x squared plus 13x plus 42. So filling in the box, that's not the answer. Okay, that's a tool to get us the answer. This is the answer. So a lot of times this year, when we had problems like this, a lot of times people just leave it in the box, but this is what your answer should look like. Okay, this is just a method to get your answer. Okay, so now this one here, again, 2 by 2. All these ones we're seeing today are 2 by 2, because they're all binomials, 2 terms. So x plus 2, x minus 5, x squared, x times 2, 2x, negative 5 times x, negative 5x, and negative 5 times 2, negative 10. Combine your like terms. So I'm going to get x squared minus 3x, because I'm combining those, minus 10. Okay, that's my answer. Okay, this one has a number in front. So 3x plus 1, x minus 3. So x times 3x is 3x squared. X times 1 is x. Negative 3 times 3x is negative 9x. Negative 3 times 1 is a negative 3. And now we're going to combine like terms. So like terms. And I get 3x squared minus 8x minus 3. Okay. Okay, x minus 2 times x minus 4. X minus 2, x minus 4. X times x, x squared. X times negative 2, negative 2x. Negative 4 times x, negative 4x. And negative 4 times negative 4 is positive 8. So x squared minus, again, like terms. Those are my like terms. Minus 6x plus 8. Okay, another 2 by 2. Okay, 2x plus 5. And I put the plus with the 5 so I know it's positive. X minus 6. X times 2x is 2x squared. X times 5 is 5x. Negative 6 times 2x is negative 12x. And negative 6 times 5 is a negative 30. So I'm going to combine these. I'm going to get 2x squared minus 7x minus 30. Again, let me just highlight my like terms here. Those are my like terms. And last one of these. Okay, 4x plus 8, 2x minus 3. We got numbers, coefficients, we call that, in front of both of our x's this time. So 4x plus 8, 2x minus 3, and I'm going to multiply. 2x times 4x is 8x squared. Okay, this is multiplying. Sometimes when all of a sudden there's a number here, sometimes I have students want to add this. This is still multiplying. Negative 2 times 8 is 16x. Negative 3 times 4x is negative 12x. Negative 3 times 8, negative 24. And I'm going to combine my terms. And I get 8x squared plus 4x minus 24. And that's the end of this portion of it, okay? So you can, at this point, submit this, okay? So I'm gonna just hit this, save it. Okay, so I saved it with the little, up here there's a little thing. And then I can, after it saves, I can just turn it in right from here, okay? Now, sometimes it'll ask you if you want to make a copy because the one the teacher has was gone. So right now it says a file your teacher copied for you was removed. You might want to make a copy because I've had some students who've accidentally deleted theirs and then they didn't have anything. So I usually just play it safe and make a copy, and it's just a blank one. So if you want to come back to it and try again, it'll be there. Okay. So again, this one here with my name, okay, is going to be the blank one because I always assign one to each of you guys. Okay. So that's the blank one. And then when you click on edited one, I've done this a couple times for different classes, you'll see that that's the one that has your work. Okay, so now we're going to go to the other set of notes. So this one actually would have been in our last packet of the year, which is review of each chapter, and we have a classwork and a homework. So the homework is the one I'm giving you guys tonight. This is the classwork, and we're going to run through this. So again, it was titled Classwork. Final review number 1 is what I titled it. And I apologize, these pictures are kind of, when they cut and pasted them originally, they are a little bit of a blur. So there's not much I can do about that. I apologize. So this is when we were learning about function machines. So this is your input, -3, x is -3. We're going to plug that in here, and we get our output out. So I am going to put in -3 into this function. So I'm going to have -2 times -3 plus 4. When I work that out, I get 6 plus 4, or 10. So f of x is 10. That is our output. I put in a -3 and I get out a 10. So this next one, I'm putting in a 2. I have 3 times 7 to the power x, so it's going to be 3 times 7 squared. And you can put this into your calculator as you see it, okay? So what I mean by that, especially if you're using the graphing calculators or a scientific calculator, it does do order of operation. So if I go 3 times 7, and then your square is right here, squared, it's going to give me the right answer, okay? It's going to give me 147. Now, if you're typing this in, you want to make sure you type it in like this, or you do the order of operation. Do not go 3 times 7 and hit enter, and then square that. That is not the right order, okay? This would make this into a 21, and the 3 is not being squared, just the 7, okay? So I'm just going to write out that this is really 3 times, and 7 squared is 49. But again, you can put that in your calculator. It will give you the proper answer lots of times. And I ended up with the top number, which was 147, and that's our answer, 147. So you just have to be careful with how you enter things into the calculator. Okay, so this time, this down here is our output. Okay, we're getting output. This is the output, not our input. I'm not putting 125 in here for the x. I'm putting 125 for that, for f of x. Okay, so I'm going to take 125 equals x to the third, and I'm going to solve that. So remember, anytime we have a power, we undo that power by taking the root. So since this was x cubed, I'm going to cube root. And if you don't know what the cube root of 125 is, you can do it on the calculator. So on the calculator, there's 2 ways to get to it. One is you can press the math button. If you press the math, number 4 here is your cube root, okay? And you could just type 4. You don't even have to arrow down, type 4. And then you can put in your 125, and it's going to give you 5. Another place, I know I've taught you guys that alpha y equal gives you all the fraction options, and alpha, which I'm still in the alpha mode, okay? Window, okay, so I did alpha window. This number 1 is absolute value. These other ones we're not ready for yet. But here, number 6, this is any root, okay? Any root. So I would, if I was going to do that one, let's say I was going to do that one, either I put the 3 in first before I do that, or it gives me space to put the 3, and then I put in the 125. What you do not want to do, and I see people do this, do not type in 3 and then go and get the square root button and then type in 125. This is not the same thing. It's going to take the square root of 125, which is not a nice number, and times it by 3, and it's going to give you some decimal. So be careful. Understand how to put things in your calculator. So x is 5. That is our answer. Okay. So letter D. Okay. -2, I'm going to put it in here. So I'm going to take the square root of -2 plus 1. Now, when we take the square root of a -2, you can try to do it in your calculator. Some of us might know what happens when I take the square root of a -2. So again, square root right here, this is your square root. It's not any other root, it's just a square root. To get that, I do second. Okay, I did the second, and then I'm going to do the square root. And I'm going to take the square root of, and you got to type in negative, not minus. Negative is down here at the bottom. That's different than your minus, okay? -2. And then when I put it in my calculator, it gives me error. It says non-real answers because we cannot take the square root of a negative. Because a square is when I multiply the same thing with itself to get an answer. And a positive times a positive is a positive. A negative times a negative is a positive. So when I square something, I should always get a positive. So this is no solution. Can't square root a negative. Now in integrated 2 next year, you actually are going to be taking the square root of a negative, and you're going to be getting something called an imaginary answer or a complex number, okay? But for us now, anytime you're taking the square root of a negative, no solution. Okay, so this next one, I know this one's not the best copy here. This is an x plus 3 over 2x minus 5. So I'm going to put a 2 in here. So I'm going to go 2 plus 3 over 2 times 2 minus 5. So sometimes you might have 2 places that you have to put in your x. Now we can do this here by hand. 2 plus 3 is 5. 4, that's going to be a 4. 4 minus 5 is -1. So my answer is -5. Now, I'm just going to show us on the calculator because many times I'll have people have this and then give me the wrong answer. So you need to be smarter than your calculator, okay? You need to understand how to put it in. So if I was to do this, 2 plus 3, because that's what it says, right? And I'm dividing by 2 times 2 minus 4. You're going to see I do not get, sorry, it was actually a -5. Let me change that. It was a -5. I do not get that answer. Because what my calculator does, it does order of operations. So we want the 2 plus 3 to be added first. It is going to first do this division, okay? And then take that answer and times it by 2, and then add it to 2 and minus 5. So if I want to do this on my calculator, I need parentheses around the top, 2 plus 3, divided by, and then I need parentheses around the bottom, 2 times 2 minus 5. And you see I get my -5. Another way to do this, and this is probably how I would do it, is if you hit the alpha y equal button, you get it as a fraction. And it will do the order of operation because it knows that in a fraction, it needs to compute the top and then compute the bottom and then do the division. So if I just enter it like that, my integrated 2s do this a lot because they get some really complicated equations with trig and things, and they can just, whoops, sorry, I got out of this. Let me try it one more time. I was talking, should be talking while I'm doing this. Okay, so 2 plus 3 over 2 times 2 minus 5, and it is going to do the right order of operation. So the next one here, we're going to be, again, having our output. Okay, you got to pay attention to whether it's your input or output. So I'm not putting 99 in here, okay? Thank goodness I don't have to square a 99. So I'm getting out a 99. What did I put in to get out a 99? So I'm going to go 99 equals x squared minus 1, and then I'm going to do this math. So I'm going to add 1 to both sides, and I get 100 equals x squared. And to undo anything to a power, I'm going to root it. So in this case, I'm going to square root it. Now, most people miss this problem because most people give me 10. But anytime you take a square root or a 4th root or a 6th root, anytime it's an even root versus an odd root, okay? And I'm talking about the little index, the little number in front. Anytime you have an even root, you're actually going to get 2 answers. So the minute I'm taking a square root, I have a positive and a negative because a negative times a negative would have given me a positive, and a positive times a positive would have given me a positive. And that's true if this had been an x to the 4th, x to the 6th, any even. you're going to have a plus minus. You're going to get two answers. And then when I take the square root of 100, I get a positive and a negative 10. So you really get two answers for this. This is commonly missed problem here. So next one. This one we probably had a little more trouble with back when we first were doing this, but we've been practicing absolute value equations, so hopefully we do a little better now. This is an output. I want to know what can I put in to get out a negative 3, okay? So negative 3 equals absolute value of x. Well, remember, when I take an absolute value of something, it's how far away is it from 0, and that's always a positive idea, positive value. So this is actually going to be no solution, because if this had been a 3, the absolute value of 3 is 3. The absolute value of negative 3 is also 3. There's no way to get a negative back. So this one has no solution. Again, another one that's missed a lot. Okay, now this one here, kind of like the one we had done earlier. Okay, again, it's not a great picture. I'm going to take 1/2 times 3 to the 4th, okay? So I'm really going to be doing 3 to the 4th first, which actually is 81, and then timesing it by 1/2. But you can put that in the calculator if you want, okay? So you can enter it in as alpha y equal, okay, alpha y equal, and then I'm going to put in 1/2, or you can put in 0.5 if you prefer, but sometimes you might have a fraction that you don't know how to change nicely. And then I'm going to arrow out times 3, and then this button here is your raised to a power, okay, raised to the power 4. And it's going to give it to me as a fraction, 81/2. So 81/2. Now, if I don't want it as a fraction, you can either do second and y equal and come here, and number 4 changes fractions and decimals back and forth. Or what I usually do, I'll just get out of that. What I usually do is, for that, I usually just hit math. Just hit math. And number 1 changes it to a fraction. Number 2 changes it to a decimal, so I'll press 2. And then it'll convert it for me. And so this is also a 40.5. So if you have a multiple choice situation, you need to make sure you can go both ways, because you don't know how it's going to appear, okay? Okay, last one of these. So on this one, it's another absolute value. So I'm going to put in a negative 4. So I'm going to take the absolute value of negative 4 minus 2. And I'm going to compute this. Now, the absolute value of negative 4 is 4. 4 minus 2 is 2, and my answer is 2. There is an absolute value, and I kind of pointed it out a second ago on this. So if I press alpha and window, this one here is absolute value. And you could type in negative 4 minus 2, and it will do that math for you if you need. Okay, so that was the first idea from chapter 1. The next idea from chapter 1 is something a function or not a function, and then domain and range. So I'm going to flip to the next page. And we're going to be looking at tables, and I do apologize, these are kind of blurry. We're going to be looking at tables, and we're going to be looking at graphs. And remember that a function is when each x goes to 1y. So I'm just going to kind of jot that down. So function each x, and I'll put in parentheses input, goes to 1y. And I'll put output. So each x goes to only 1y. I cannot have an x go to 2 totally different y's. We did this with the soda machine problem, where we pressed the machine, and one time we pressed 1 and we got, I forget what the names of them were, some soda out, and then we pressed that same button, but a totally different one came out. So that's what's going on with these. Now, we had done these problems, so a lot of these problems look like a review from before, and we have seen these. And what we want to look at is our input, okay? So I've got 1, I press 1, I get sticks out. I press 1 again, I get sticks out. So that's okay, because every time I press 1, I get sticks out. Now I press 2 and I get M&Ms. I press 4 and I get M&Ms. It's okay to have more than one button that gives me the same candy. Maybe it's a really popular candy and they have it in more than one spot. So that's okay to have 2 go to M&Ms and 4 go to M&Ms. The problem is that here, 2, and I press button 2, I got M&Ms, but then the next time I press button 2, I got duds. This is our problem. This X, this input, has 2 totally different outputs. That's not a function. So it's okay that 2 different inputs go to the same output. It's even okay that these 2 go to the same output, but having the same button or the same input go to 2 totally different outputs, that's not okay. So this one is not a function. I'm just going to write no or yes, okay, just to shorten it. So this is no, not a function. Now this one here, I'm going to zoom in. When you're looking at this, remember each X has to only go to one Y. So when I'm doing this, if each of my X's is not repeated more than once, okay, so up here, all of them are only once, then this is going to be a function because I don't have 2 different X's. I don't have the same X listed to go to 2 different values. So since I have no repeats in my input, no repeats in my X's, this one will be a function. This is going to be yes, a function. Now, the next one here, let me zoom in again. So here, as you're scanning, okay, don't see any repeats, no repeats, wait, 2 and 2. Now, it's okay to have 2 and 2, but they better go to the same thing. So when this 2 went to 9, and this 2 went to -8, that's a problem. That is not going to be a function. So this is going to be no. Okay, now we're going to be looking at graphs. When you're looking at graphs, you still have that idea that each X goes to one Y, but when it's on a graph, the way you're going to think about it is using what we call the vertical line test. So I'm just going to jot that word down. So I wrote here, vertical line test, that's what we use, okay? And it's a function if the vertical line only crosses the graph once. So the reason we do a vertical line is because a vertical line is X equal. So I'm looking at each X. So when I used to do this in class, I usually had like my little lead, and I had my little piece of lead from my mechanical pencil going across, and we would use that as our vertical line, okay? So I'm just going to draw a vertical line. I'm going to do it in like a yellow so we can kind of see it. I'll use a little fatter one just so we can kind of see it a little better. So if I was to draw a vertical line here, I'm drawing it through -3, okay? And when I did it, now it's hard to see. Maybe I'll use a highlighter. I'll get a thin highlighter. Okay, purple should be fine. Okay, so I'm going to draw a vertical line. And when I draw my vertical line, you see it's going to touch there once. And if I was sliding this vertical line across, and let me just move it over here, it only touches once. So everywhere I'm drawing that vertical line, if it only touches once, then it is a function. Now, for example, right here, let me just kind of zoom in. When I drew this one here, I was looking at -3, X being -3, and X being -3, there was only one Y here at 1, -3, 1. This one here at -2 has 1. This one here has 1. That's why we draw a vertical line. So it's showing us if it goes through one point only, that X has only one Y, one output. So when we go to a graph like this, so I'm going to write it here in a second. Roman numeral 4, that is a no. Okay, let me write it before I don't. So that is a no. Oh, sorry, that was a yes. That was a function. Wow. Out of sight, out of mind. Yes, that was a yes. This one here, and this is why I was kind of saying no. Let's say I draw a vertical line right here where X is 0. This is where X is 0. And you can see that this crossed 1 time, 2 times, 3, maybe 4 times, depending on where that little point is, 5 times. So at least 5 times this is crossing. This x, 0, has 5 different outputs. So this is no, not a function. That's why we draw a vertical line. Okay, so they're giving us another table. And again, sorry, the original copy is blurry, so this is blurry. So as I'm looking at this, again, you're scanning your x's to see if you have repeats. If you have no repeats, then it's going to be a function because you don't have anywhere for it to be a problem. But as I'm doing repeats here, let me just get a yellow this time. As I'm going through, okay, I see a couple things. I see 4 goes to 3 and 6 goes to 3, but that's okay. I can have the different x's go to the same output, okay? Maybe it's a popular output. But I do have a -8 here, and I have a -8 here, so maybe this is a problem. But it's not, because they go to the same thing. So here, -8 goes only to 11. Yeah, I have it twice, but I didn't have -8 go to 11 and -8 go to a totally different number. This is a function. So this will be yes. And this one here, again, let me get a vertical line. So if I draw a vertical line, okay, no matter where I draw my vertical line, it's only going to touch one spot. So this is a yes. So now we've talked about function machines, finding an input or an output depending on the situation. We talked about functions. Now we're going to talk about domain and range. So these graphs here, they're going to ask us for domain and range, and then it asks us to state whether or not the graph represents a function. Okay, so I'm just going to make a little note here. Domain are your x's. And so I'm going to put D. Domain equals your x's. And x's are left to right. How far to the left does the graph go? How far to the right does the graph go? Okay. Choose green. Your range, now put R, is your y's. And this is how high up and how far down. So it's up and down. Okay, how low and how high. That's your range. So I'm going to kind of color code here with my pen. So if I'm looking at my domain, I'm looking across the graph, furthest to the left, furthest to the right. And I'm going to kind of zoom in a little bit more. I know the graph's not that great, but we can kind of see at least where I am. So the furthest to the left it goes is here. That's the furthest to the left it goes. And that's -3. The furthest to the right the graph goes is right here. That is +3. Now it touches at -3 and +3. So we're going to do it in what we call interval form. We're going to put a square bracket. That means it actually touches. -3 is an actual value on my graph. And it goes to 3, again, close bracket. Square bracket, but we say close bracket. Now when I'm doing my range is how low and how high. So how low does the graph go? Well, the graph goes all the way down to here, and that is -3. And it goes all the way up to here, which is a +3. So again, close bracket, -3 to 3. And then if I was to use the vertical line test, this is definitely not a function because as it's going across, it's touching twice, many places. So this is no, not a function. Now, letter B, we have a line, okay, a diagonal line, and I just want to emphasize that these do have arrows at the end. There's an arrow here, and there's an arrow here. Now, what a lot of times people do is they look at the graph and go, oh, it stops at -4. Oh, it stops at 4 because those are last numbers. But do you see this arrow? This means it keeps going down forever, but also left forever. And then this keeps going up forever, but also right forever. So in terms of domain, this graph, again, how far to the left? It's never going to stop as I'm going to the left. So it's going to be infinity. Now, infinity you can never reach. It's going to be negative infinity because I'm going negative. When I say negative, I mean left negative wise. So that's negative infinity. And then, yes, it's going up, but as it's going up, it's also going right forever. So negative infinity to infinity. Again, both open brackets, we write parentheses. Now range, okay, that's your up or down. So how far down? Again, this is going to go down forever and ever and ever, so that's negative infinity. It's also going to go up forever and ever and ever, so that's positive infinity. Again, infinity, you never reach, open brackets. Is this a function? Yes, because as it goes across, it's only going to touch once no matter where it is. So this is yes. Now, the next one looks almost identical to this. This is a line. This is a line segment. Okay, so this one actually has ends to it where this one doesn't. And these ends have closed circles versus if it had, for example, an open circle, then this particular value would not be included. And I would use one of these types of parentheses. It would be open because it doesn't quite reach there. It goes up to, but doesn't reach. But in this case, it is closed, okay? So the furthest, let's do domain again. So the furthest this graph goes, to the left, looks like it stops right here. Okay, so right here, it looks like that would be at -2. And the furthest to the right this graph goes is here. And that looks like that is at 4. So it goes to -2. And again, because it's a solid dot, it's a closed bracket. And it goes up all the way to 4. That's your domain. Now my range, how far how far down and how far up. So how far down, it's going to stop right here. So it's going to stop at -4. And how far up, it looks like it's right here. And that is going to be a 2. So this is going to be -4 to 2. And again, as I'm going through this, it's only going to touch once. So this is a function, yes. So D, this is a parabola. This is what those quadratics that we were talking about on the other worksheet looks like. This is a negative parabola, okay, a negative quadratic. Now I'm going to add, because I think there are supposed to be arrows at the end. I think this kind of got cut off here. So let's give this arrows. Okay, it keeps going down forever and ever and ever. So when I'm doing domain, again, it's how far to the left. Now, as I'm going to left, don't stop at -4 because not only is this going down forever, but as it's going down, you see how it's going also left forever. And this is not only going down, but it's also going right forever. So this is going to be -infinity to infinity because it's going to keep going left forever and it's going to keep going right forever. Now my range, how far down does it go? Well, it keeps going forever, so that's -infinity. But it doesn't go forever up. It comes and it stops right here. And I think it stops right here. So that's 1, 2, 3. Looks like it's going to stop up at 4. And that's going to be a closed bracket because it actually touches at 4. Okay. Anywhere where you have a line, or in this case, a curve drawn, those are points. Okay. They don't need to put an actual like dot. These are all points, infinite amount of points. So when it gets up here, that is included. And then if I do my vertical line test as it goes through, everywhere it touches only once. So this is yes. Now this graph here, okay, I'm going to zoom in because this is kind of a small little graph here. So for my domain, how far to the left it goes right to here. So it looks like it stops right here. Let me just put the little mark. It looks like it stops at 2. And it goes here, it looks like it stops at 4. So from 2 to 4. So it's going to be close bracket 2, close bracket 4. And then how low does this graph go? Looks like this graph goes to -3. And it goes up here. It looks like it stops right here. So it looks like it stops at 2. So it's going to be -3 to 2, both close brackets. And as I'm going through this, let me get rid of these for a sec so we don't have those there in the middle of it. If I was to draw my vertical line, You see here, I ended up crossing 1, 2, 3 times. So is this a function? No, not a function. Crossed 3 times. Okay, this graph, okay, you'll be seeing a graph like this in integrated 2, and especially even more so in integrated 3. It's more focused in that. This is a square root graph. It's actually half of a sideways parabola, which would be the quadratic we saw earlier, the parabola. But regardless of the type of graph it is, this graph ends right here. So as I'm coming here to the left, the furthest it's going to come is to here. I'm going to put the line, I'm going to get rid of it here in a second because we're going to need to be able to read that. So here is the furthest to the left, and then it goes forever and ever and ever to the right. So that's going to be closed, 0, open, infinity. Now, let me get rid of this so I can see the little grid marks. Okay, so now I'm going to look at my y's, my domain. So how low does it go? This actually goes right to here. So this looks like 1, 2, 3, that's 4, 5. So it looks like it's at 3. It's at 3. And then as it's going here, it's going out to the right, but it's also gradually going up. So this is going to go to infinity. And is this a function? Yes, because as this goes across. So hopefully this will be helpful for your review for your final and for tonight's homework.